Okay, so in this video, section 4.5, we're going to actually start talking about the derivatives of natural logs. Up until now, we've been talking about derivatives of exponential functions, but now we're actually going to start talking about derivatives of logarithms. So the first thing we want to go through is the rules, the derivative rules for natural logarithms. They're pretty straightforward, and you probably want to have these rules by your side when you're working through these problems, because even though they're straightforward, they're easy to forget. Mainly, anytime you take the derivative of the natural log of x, the derivative of natural log of x is going to be 1 over x. Pretty straightforward, pretty simple. With the restriction that x has to be greater than 0. Now, if you take the derivative of the natural log of g of x, of a value that's more than just x, then the derivative of the natural log of g of x is going to be the derivative of whatever you're taking the natural log of divided by whatever you're taking the natural log of. So, for example, if you're asked to find the derivative of f of x equals natural log of 3x, you're going to say the derivative of 3x is 3, so you're going to say 3 over 3x, which simplifies to be 1 over x. But it's always the derivative of what's inside the natural log divided by what's inside the natural log. And then lastly, the derivative of the natural log of an absolute value of x is 1 over x with the restriction that x cannot equal 0. And we'll talk a little bit more about that later on. Okay, so for example, let's differentiate this function. We want to find y prime of x here. So to differentiate this function, remember we have to differentiate this term and this term separately. So to find y prime, remember this is a natural log function, so we're going to take, remember the derivative of the natural log function is going to be g prime of x divided by g of x. So the derivative of what's inside the natural log here is just going to be 1, and then g of x is going to be x plus 6. So that's the derivative of this function. And then the derivative of natural log 3 is going to be the derivative of 3, which is 0, over 3. So now, to simplify, we get 1 over x plus 6 plus 0. So the derivative of this is going to be 1 over x plus 6. So let's try this one. Again, we're going to have to differentiate these two terms separately. Whoop. Hold on. So to differentiate this first term, we're going to have to use the power rule here. So we're going to say 4 parentheses natural log x. Now we're going to differentiate what's inside the cubes, excuse me. Now we're going to differentiate what's inside the parentheses. Remember the natural log of x is just 1 over x plus, and then when we do this one, do you see it's a little bit different situation here? We've got the natural log of x to the 4th. So in this case, we're going to again do g prime of x divided by g of x. So g prime of x is going to be 4x cubed divided by, and g of x is going to be x to the 4th. So now, if we want to simplify, we get y prime equals 4 natural log x cubed over x plus this cancels with this, so we get 4 over x. So y prime comes to be 4. We can factor a 4 out, and we're left with natural log x cubed plus 1, all of that over x. Okay, and so here's a problem with division in it. So we're going to have to use the u and v designations. So if we're going to differentiate this function here, first we have to set u equal to natural log x plus 1, v equal to x, u prime equal to, remember the derivative of natural log of x is 1 over x, the derivative of 1 is just 0, and v prime is going to be 1. So, to find the derivative of this, we're going to have to do vu prime minus uv prime over v squared. So we're going to have x times 1 over x minus uv prime, so minus natural log x plus 1, all over x squared. So to simplify here, do you see the x's cancel? And we get 1 minus natural log x, and then when we distribute the negative here, we get minus 1 over x squared. And do you see the 1's drop out? We've got 1 minus 1, so we have natural log x over x squared. So the derivative, f prime of x here, is going to be negative natural log x divided by x squared. Negative. Okay, and then the last problem we're going to try to differentiate here looks like this. We've got the natural log of e to the 2x plus 1, all of that squared. So we've got a couple different things going on here. First thing we want to do is look at the power rule here. So we're going to say 2 parentheses natural log e to the 2x plus 1, and we are going to raise that to the first power. Now we have to differentiate what is inside the function. So now we have to differentiate the natural log of e to the 2x plus 1. So remember, that's g prime of x divided by g of x. So the derivative of e to the 2x plus 1 is going to be 2e to the 2x, and then the derivative of 1 is 0. We're going to divide that by e to the 2x plus 1. So now what we want to do here is simplify a little bit. So change our color here, and we're going to have 2 times 2, so we'll have 4 e to the 2x natural log e to the 2x plus 1, and then in our denominator we're going to have e to the 2x plus 1. And that looks like about as far as we can simplify. Do you see that we have e to the 2x plus 1 in 2 places, but this one is inside a natural log? So since it's inside a natural log, you can't cancel it with the 1 in the denominator. So anyway, I hope this helps you work through the prep quiz. Just be sure to keep those properties next to you and work through the prep quiz, and we will talk about it a little bit more on Wednesday.